This is our second screencast on pointers, and we're going to talk a little bit about arrays and pointers, and we're going to start with just a plain old car array. So I'm going to put a car array called full name, and I'm going to take a constant string, my name, with a new line character. I'm going to put this in a variable so that it lives in RAM. And then what C++ does is if you just see out the name of the array without using the array index operator at all, it just turns this into a pointer to this, and it'll print it out till it hits a null character, /0, which, as you recall, with these double quotes is automatically added to the end of the string. So this really does the same thing as this. So here I'm using the address of operator. I'm saying take the address of the first element. So I'm kind of explicitly asking for a pointer here, and this is C++ doing it by itself up here. And then if I don't use the address of operator and I do that same thing, this will give me just one character. So I'm going to print out a new line, and then this says give me the address of where the array lives. So this is not at all like this. This is just going to give us some hex address about where the beginning of this string lives in memory. So let's go ahead and build that, and then we'll run, and we'll see that. So there we go. So when we see out full name or the address of full name of 0, we get the full name. When we just put out the index, we get the letter, and then you can see in the final case that we get a hex address. So this acts sort of like a pointer, but it's not quite as good as a real pointer. And let me bring up some more code here. Normally you can do pointer, what's called pointer arithmetic. Like you can hit ++ on a pointer, use the pre-increment, and it'll point to the next element in the array. And in this case, if you just try and do ++ on full name, since you didn't declare it as a pointer, this is not going to compile. But this will. If you say, okay, I've got a pointer to a car, it's called P full name, and it points to full name. So now I've actually declared a full up pointer using that syntax, and it's pointing to the same place. Now I can say ++. I use the pre-increment, or I can say P full name equals P full name +1, or whatever we want. I can increment the value, do some arithmetic, and now when I do a cout on this, it's going to skip over the first character. Okay, so I'm going to put a return here, just so that we don't have to worry about the rest of that stuff. Why I put parentheses. Okay, and did I get rid of my, I think I did get rid of my previous return. So let's go ahead and compile that, and let's run. And there you go. So there's our original 2, there's the T, there's the address, and then there's that message using an array, and you can see I've skipped over the first character using pointer arithmetic there. Okay, so let's get rid of that return. And what I want to do is now I'm going to do ---- so that I point back to the beginning of name. And I also could have just reassigned P full name. I would leave that piece off, and I could have just said P full name equals full name. That would have moved my pointer as well. So then I'm going to do one of these little things I kind of mentioned earlier in previous classes, where what I'm going to say is dereference P full name. So you dereference this, and then I'm doing a while on that. So what I'm really doing is I'm saying while this is anything other than a 0. So while we're not at that that /0, that is that null character, that guy, while we're not on that, keep doing this loop. And so what I'm going to do is I'm going to say, okay, whatever you're pointing at, dereference it, give me that character, send that out, and then also send out a hashtag. And then I'm going to increment the pointer to point to the next character, and I'm just going to keep doing this. And when I get to that termination character, then I'm going to put out an extra line feed. Okay, so let's okay, so I took out my return there, so let's put a return here so that we stop after that, and let's compile that. Okay, so you can see everything above us is the same as it always was. That's all still there. But now, so here's where I moved past, and then I moved back. So there's my T, my whole name. And remember, I had a new line character buried in my name. So it actually printed the new line, then it printed a hashtag, then it printed the final new line here. All right, so that gives you one idea of kind of the things you can do with pointers. So let's go on. Let's get rid of this, and let's deal with a array of ints. Now you remember, ints, each int in our system, everybody check this, everybody's int was 4 bytes long. Okay, so this means we're going to create an array of 4 numbers, each of which is 4 bytes long. So this is going to take up 20 bytes of memory. And then I'm going to create a pointer that's going to point to the beginning of this array. So it's going to point here. Okay, then I'm going to say cout dereference what this points to and print that out. And so you probably at this point understand that will print out the value of 1 and then a new line character. But now if I do plus plus on the pointer, what does this do? Up here, we saw it move it through the character array. The character array all the way up here, but each car is 1 byte long, right? So it wasn't too surprising that incrementing something by 1 moved us 1 byte in memory. But pointers are smart, they know what they point to. So this pointer knows it points to ints. So it's saying, oh, you're incrementing a pointer that points to an int. I'm going to move you 4 bytes and I'm going to point to the second item. And then every time you do that, it's just going to keep pointing to the next int like that. So we're just going to do it once here for now, and just so you can see it work. And we'll put the return 0 in there, and we'll build that, and we'll run. Okay, so you can see it printed out 1, then it printed out 2. And if these had been doubles, which were 8 bytes, it still would have worked. Matter of fact, I can do that. So let's just change this to a double and not a capital letter. And change this to a double. And we'll just hit F2 here and we'll do a rename. And we'll call that double array. Actually, we don't, and actually we'll do that same thing here. Let's call this pointer to double. Okay. And then let's go ahead and compile that. And we should get the same results. Actually, we got an error. It didn't change this name for some reason. My rename refactoring has a flaw. Okay. All right, there we go. And there you go. It still prints out 1 and 2. So it moved by 8 bytes for each time it saw that.